Guys, we're going to take a look at part of our break packet for spring break 2018. And I know some of you guys wanted me to get this up a little earlier, so my apologies, it's not happening until Friday. But let's take a look at some of these together. So first I want to say I'm not going to go over every one of these problems because it's very, very important that you get some practice doing some of your work completely independently because we are very close to our New York State exam and you've all worked really hard and we have to just really hit the gas pedal for about another month. And then we'll get through this exam and then we're prepping for 8th grade algebra. So I hope you guys have an awesome break and I hope that you work really, really hard on all of your break packets so that when we are taking state exams, you're able to prove how hard you've worked all year. All right, add them all. Sarah bought 3 sweaters. 2 of them cost the same amount and the third cost $22.50. If Sarah spent a total of $58.50, how much did each of the 2 equally priced sweaters cost? Okay, well, I'm going to read that one more time. So she bought 3 sweaters. Okay. 2 of them cost the same amount, and the third cost $22.50. If Sarah spent a total of $58.50, how much did each of the 2 equally priced sweaters cost? Each of the 2 equally priced sweaters cost, okay? So I don't have a ton of room for a key information box, but I'm going to make one. Okay, I know that she spent a total of $58.50 on 3 sweaters. And I know that one of those sweaters was $22.50 and the other 2 were equal price. Okay, so I think I can make an equation here that's going to help me out. I'm going to say 22.50. Actually, you know what? It's easy, harder for me to write small in this area. So I hope you got that key information box down. So I'm going to say, here's my equation. 22.50, that's the cost of one sweater that we know, plus 2S, and that S there represents the 2 sweaters, is equal to 58.50, and that's the total that Sarah spent, okay? I do recommend using scientific calculators for these because you will have access to a scientific calculator on the state exam. So I'm going to plug in 58.50, I'm going to subtract 22.50, okay? And that's going to leave me with 2S equals 36. And I'm looking over here, and A is assuming that I'm going to forget this last step. So some students are going to look at this and go, okay, 36 is my answer. I'm going to circle 36, but that's not my question. My question is, how much is each of these sweaters cost? So I'm going to divide by 2. I'm going to get S is equal to 18. Okay, 36 times 2 is 18. So each of the sweaters was $18. She got a pretty good deal. Okay, so let's move on to our next problem. Which of the following, I'll change color so it doesn't get all mixed up. Which of the following does not show a proportional relationship? Which of the following does not show a proportional relationship? So in order to decide which one of these is not a proportional relationship, we have to remember what makes a proportional relationship. And so a proportional relationship is essentially when you have the relationship between the 2 variables, between the x and y, is constant. And we've learned earlier this year that k for constant is equal to y over x. Write that down up here. We have our k is equal to y over x, and that's how we can get our constant. So I'm going to start here with a is equal to b over 2, which could be proportional. I'm going to come back to this one. B, I have y equals 5x plus 2, and so when we're looking at this in terms of graphing, which you'll do a little bit this year, a lot next year, this is a linear equation. But this 2 right here, and it's y equals mx plus b. Okay, and this 2, or this b, means it's the y-intercept. So what that means is on this line, the line is going to pass through 2 on the y-axis, okay? And then it's a slope of 5, so it's going to go up 5 over 1. But the point here is that this cannot be a proportional relationship because it doesn't pass through the origin. So I think B might be the one that I'm not interested in here. I don't think this is proportional. All right, Caesar sells 3 pounds of candy for $15. Oh, and it says here every 3 pounds of candy for $15. So we know that 3 pounds is going to be $15. We know that 6 pounds is going to be $30, and on and on and on. And then we know that 0 pounds is $0. So that would pass through the origin. For D, a graph which shows a straight line passing through the point 0, 0. So this does pass through the origin. If you remember, 0, 0 is the origin. So this is also proportional. Okay, so my y equals 5x plus 2 is the equation here that is linear. It is a line, but it is not proportional because it does not pass through the origin. Let's move on. All right, we're going to do some simplifying of expressions. I am going to do the first one. I'm going to leave the second one for you guys to do. So in order to do this, I'm going to have to do some distributing. Okay, so I'm going to distribute the 4 to the x and to the negative 3. I'm going to be left on this side with 4x minus 12. And then over here, I have my 5 that I'm distributing to the x and to the negative 3. So I'm going to add plus 5x minus 15. Okay. And now I have some terms that I can combine. I have 4x and I have 5x, and that's positive, so I can be left here with 9x. And then my other terms that I can combine are negative 12 and negative 15. When I combine a negative plus a negative, it becomes more negative, right? So it goes further left on the line. So we'll do 15 minus 12 is going to give us, 15 plus 12 is going to give us 27. So it's going to be negative 27. So my final answer here when I've combined these is 9x minus 27. Okay. Now down here, you're going to have to do some simplifying. And yes, you are going to have to, actually, I want to do this one for you because I don't think I've seen one like this in class before. Okay, so I do have to distribute this a 2x to the y. And so what that's going to give me is 2xy plus, and then 2x times 3. So that's going to be plus 6x. Okay, minus 7x plus 5xy. All right, and I do have some like terms here. I can combine my 2xy. I can combine my 5xy. I'm going to get 7xy. All right, and then I have 6x. And I have negative 7x. So that's going to be minus 1x, or just minus x. Okay, I can't combine this xy with the just x because I don't know what y is. All right, so there's no way I can do anything funny here right now to combine this any further. Number 4, which equation represents the relationship between x, the number of cherries, and y, the cost. So I'm looking for the relationship between x, the number of cherries, and y, the cost, okay? So I need to find my constant. I'm going to go k is equal to y over x, all right? So if I do 5.5 over 22, I want to use some whole numbers here. Okay, so I'm actually going to erase this because I want to use this graph a little bit here. What I'm going to do, I want to work with the whole numbers, but I am going to work with all of them. I'm actually going to make like a third little chart here. All right, and that's kind of my x over y. That's going to help me find my constant or my unit rate. So when I put, sorry, it's y over x, I'm going to put 5.5 over 22. I'm going to put 8 over 32. Okay, and I know that gives me 1/4. I'm going to put 10.5 over 42. And I'm going to put 13 over 52. Okay, so these should all come out to 1/4. So when I do 5.5 over 22, okay, I do get 0.25. So that is 1/4. 10.5 into 42, yes, that is going to also be 0.25 or 1/4. And then 13 going into 52 is also going to give me 1/4. Okay, so I'm looking for an equation that is essentially telling me that the relationship between x and y, or the constant between x and y, is 1/4, or that each of these cherries is essentially going to cost 25 cents. Okay, so I have y is equal to 4x. So what this would tell me that each cherry is $4. That's not going to work out. We know that that's not true. Now I have x is equal to 0.25 y. So if I were to have one cherry, and it would equal 0.25 times y. No, that's not going to do it for me either, okay? Now I have y is equal to 0.25x. This is looking a little better. So this is my cost in dollars is going to be equal to 0.25 times x, my number of cherries. And we see that here. If we look at this one, this is kind of the easiest one to take a look at visually. When I bought 32 cherries, it cost $8. So if I were to go y equals 0.25 times 32, I would get $8. X equaling 0.25, that doesn't help me, right? Because then that would imply that I'm going to get 0.25 of a cherry, and it doesn't do anything with the cost. So my answer here is C, and I'll prove that here to you now. So if I do $8, right, so 8 is equal to 0.25, excuse me, times 32, that is going to come out to 8. 8 does equal 8, all right? So C is my correct answer here. Let's move on to number 5. A school principal wants to determine which type of speaker the students prefer to invite to an assembly for the entire student population. Which survey method would produce a representative sample? I'm going to read that again. All right. A school principal, wants to determine which type of speaker the students prefer to invite to an assembly for the entire student population. Now, when I first read this, I'm glad I'm reading it again. I was thinking speaker like the speaker that plays music, but it looks like, we're talking about a speaker, somebody to come talk to the kids for an assembly for the whole population. So it's the entire student population that he wants or she wants to understand. Okay, which survey method would produce a representative sample? Meaning, what would we say is a fair survey? We want to select all that apply. A survey of 5 students from each homeroom. I'm liking that so far. I'm not going to rule this one out. I think it might be nice. A survey of every fifth person who shops at the mall, that's not going to help me very much. Maybe a lot of kids go shopping at the mall, but there's still going to be a group of students who don't shop at the mall who are not represented in this survey. Survey all of the students on the student council. And student council is great, but typically the kids on the student council tend to have a little bit of a different preference than, say, kids who are on sports teams or kids who are in detention every day. So we're going to cross that out too. We don't like that one. A survey of every 10th student leaving the building at dismissal. Well, assuming, right, that every student goes home at some point, surveying every 10th student does seem like it could be okay. I'm not really ready to cross that out yet. A survey of all the students who went to the last basketball game. Again, we love our kids who go to basketball games, but they are not representative of our entire population. So it looks like the two answers here that I'm left with are going to be a survey of 5 students from each homeroom and a survey of every 10th student leaving the building at dismissal. I don't know which one of those would be better. I think it depends on the number of students in the school, but I think either of these would be an okay way to get a representative sample. All right, guys, we want to simplify this expression, and we're going to have to use our distributive property. So I have 2 cases here where I'm going to distribute. The first thing I'm going to distribute is this negative 1/4 to the x and then to the negative 8. So when I do negative 1/4 times x, I'm going to get negative 1/4 x. Negative 1/4 times negative 8 is going to be positive 2. 1/4 of 8 is 2. And then I have to distribute this 2 over here. It's a positive 2. I'm going to distribute it to the x and to the negative 3/4. So I'm going to get plus 2x, right? That's from distributing here. And then 2 times negative 3 over 4. So I'm going to pull up here. 2 over 1 times negative 3 over 4 is going to give me negative 6 over 4. So I'm going to have minus 6 over 4. Okay, and if I simplified that, that would be 1 1/2. So let me go through and actually do that. So I have negative 1/4 x plus 2 plus 2x minus 1 1/2. All right, well, let's see what I can combine here. I can combine my negative 1/4 x and my positive 2x. And that's going to leave me with a positive number. It's going to be positive 1 3/4 x. And then I'm going to combine my positive 2 and my negative 1 1/2. And that's also going to leave me with a positive number. That's going to leave me with positive 1/2. Okay, so I'm left with 1 3/4 x plus 1/2. Looking at number 7, Paula wants to know the type of music the band members at the middle school prefer to play. Who should she survey? Okay, she wants to know the type of music the band members at the middle school prefer to play. So this is one of the cases where, like, my representative sample is very specific. For this question, I only care about what the band members think, okay, because it's what they like to play. So if we go talk to the students in the cafeteria, that's not going to help me out because I don't necessarily know that all of those guys are in the band. The students in Mrs. Patel's music class, I'm not really sure. I don't know if they're in the band. They might be. I'm not ready to cross this one out. Okay, the students in the school band. I think bingo, that's the one, right? School band, it's not going to be huge. You can probably interview all of them pretty easily. That's what I'm going to go for here. And then 1 6th grade advisory, obviously, unless that 1 6th grade advisory is the whole band, that's not going to work. Mrs. Patel's music class might have kids that are not in the band. She might have kids that are in the choir too. All right, so my best answer here is this very specific students in the school band because that's who I want to know about. All All right, so I want to write an equation based on the table. This is another case where I'm doing my k is equal to y over x. Okay, so the first thing I'm going to do, I'm going to make sure that this is proportional. Here is my trick for making sure that a graph is proportional. It is cross multiplying. So 2 times 10 is 20, which means 4 times 5 should also be 20. And it should work here too. It should say 4 times 15 is 60, and 6 times 10 is also 60. Okay, so I'm good. I know that it's proportional. I know that when I cross multiply, I'm getting these same numbers. So now let's throw a y over an x. So I'm going to get k is equal to 2 over 5. Now, is that true? If I were to put k is equal to 4 over 10, does that equal 2 over 5? Yeah. Does 6 over 15 equal 2 over 5? It does. Okay. So my answer here is k is equal to 2/5. All right. Mr. Shand has a collection of X books. His apartment is getting too full of books. So he donates 32% of his books to a library. Which expression does not represent the new number of books in Mr. Shand's apartment? Okay, so Mr. Shand has a collection of X books. His apartment is getting too full of books. He donates 32% of his books to a library. Which expression does not represent the new number of books in his apartment? Okay, so I am going to do kind of an OPN here for my key information. OPN, all right? So I don't know the original, okay, and I don't know the new, but I do know that he went down 32%. So I know that he kept 68% of his books, okay? So if I do x minus 32x, so for example, let's say he had 100 books. If I did 100 minus 32% of 100, I would be left with that 68%. So I'm okay with that. B equals 68x. Yep, I think that works too, right? Because he's keeping 68%. Now I have x minus 68x. So in this case, that's going to leave me with 32%. That's not going to tell me how many books he has in his apartment. That's going to tell me how many books he gave away. And then here I have 1 minus 0.32x, which would also work. Okay, so I have these three that do work, which means that's not the answer. Not the answer, not the answer. Because this one does not represent how many books he has in his apartment. It represents more how many he gave away. I am going to circle that. Moving down, I'm going to do one more in this video, okay, because this is a 6-page homework, so I'm going to do videos 2 pages at a time. Jerome earns $200 per month plus $12 for each bike he sells at the bike shop. This month, he wants to earn at least $400. Write and solve an inequality to determine the least number of bikes Jerome can sell and still reach his goal. All right, so he gets $200 per month. Plus, he gets $12 for each bike that he sells. Okay, so that's a commission that's not based on a percentage. Okay, he gets $12 as sort of a flat rate for each bike. This month, he wants to earn at least $400. Write and solve an inequality to determine the least number of bikes Jerome can sell to reach his goal. All right, so in my key information box, okay, I have that he gets 200 as his base per month. I know that he gets $12 per bike he sells. I know that he wants greater than or equal to $400 for the month. Okay, so I'm going to go 200 plus 12x we want that to be greater than or equal to 400. That's my equation. And you guys are getting pretty good at this. So I feel confident that when we see these on the test, you're going to really crush them. All right, so now I'm left with 12x is equal to 200. I'm going to divide both sides by 12. I'm going to go 200 divided by 12. Divided by 12. And I get this crazy number. I get x equals 16.666, and it goes on and on and on. Okay. So I can't sell 0.666666667 of a bike. So I'm going to say he needs to sell at least 17 bikes. Okay. So we're going to say Jerome needs to sell at least, so that's greater than or equal to 17 bikes. All right. So that he can walk away with that $400 month. Okay. All right. I'm going to be back a little bit later with 2 more pages. I hope you guys are working really hard and that you're having a great break. See you soon.